to our presentation today. Let's talk about deciphering the world of large language models. Understanding large language models. Today, let's start and explore about what LLMs are. LLMs are a groundbreaking technology reshaping the landscape of artificial intelligence. LLMs represent the cutting edge of how machines process and generate text, fundamentally altering our interaction with technology. Our exploration will cover the basics, advancements, and implication of these models. Let's dive into the world of LLMs, understand their significance in the realm of AI. So, what are large language models? Large language models are advanced AI systems specifically designed to understand, interpret, and generate human like text. These models are built upon vast amount of data, enabling them to mimic human language capabilities. The real power of LLMs lie in their ability to handle complex language tasks such as translation, summarization, and even creative writing. The evolution of LLMs marks a significant leap in making AI communication more fluid and natural. So here is a trend in the number of LLM models introduced over the years. So we can see the blue one signifies open, orange is closed, and gray is all. So if we look at the open one, it is always on an upward trend. So the backbone of LLMs. At the core of LLMs are three critical components, that is tokenization, attention mechanisms, and positional encoding. Tokenization breaks down language into smaller manageable units for the model to process. Attention mechanism allows LLM to focus on relevant parts of the text, enhancing understanding and generation capabilities. Positional encoding adds contextual awareness, enabling the model to grasp the flow and structure of language. So here is a flow diagram which is depicting various stages of LLMs from pre-training to prompting. Prompting LLMs to generate responses is possible at different training stages like pre-training, instruction tuning, and alignment tuning. So here we have our data which we put it into a pre-training stage, and then we have instruction tuning. We have a reward mechanism. So here we use a reinforcement learning wherein what where when the LLM generates an answer, there is a human labeler which says that this answer is good for this particular prompt or the question, and this way the LLM like learns that where does it gets the where it gets the maximum reward is the path it kind of chooses. This is the loop here, and then we have an aligned LLM. Next, let's talk about training large language models. Training an LLM is an extensive process, starting with pre-training on large data sets. During this stage, the model learns the general nuances and complexities of language. The foundational training is critical as it equips the model with broad understanding of language, patterns, and structures. Pre-training sets the stage for the specialized capabilities that are honed in the subsequent fine-tuning process. Fine-tuning for specific tasks. After pre-training, LLMs undergo fine-tuning to tailor them for specific tasks or applications. This stage involves training the model on task-specific datasets, allowing it to adapt its learned language skills to particular requirements. Fine tuning is what makes large language models versatile, enabling them to excel in diverse applications from chatbots to literary analysis. It's a crucial step in transforming a general purpose model into a specialized tool. Next, let's talk about efficient fine tuning methods. LLMs benefit from innovative fine tuning methods that focus on efficiency. Techniques like prompt tuning and adapter tuning update only a subset of the model's parameters. The targeted approach saves computational resources while maintaining the model's core capabilities. These methods allow for rapid adaptation of LLMs to new tasks, making them more accessible for a variety of applications. Next, let's talk about applications of LLMs. So, LLMs have a wide range of applications, transforming industries and sectors. They are vital in natural language understanding and generation, powering systems like chatbots and virtual assistants. Large language models are also a crucial play a crucial role in context creation, from writing assistant to generating creative content. Their versatility extends to the field like education, where they can personalize learning experience. Scaling challenges. Training large language models presents significant scaling challenges due to their size and capacity. To address this, techniques such as data parallelism, tensor parallelism, pine and pipeline parallelism are employed. These methods distribute the computational load, making it feasible to train these large language models. Efficient scaling is key to harness the full potential of large language models, enabling them to handle ever increasing amount of data. Ethical considerations. As large language models become more capable, ethical considerations come to the forefront. It is essential to ensure that these models produce outputs that align with human values. Alignment tuning focuses on making LLMs produce helpful, honest, and harmless content. This involves continual adjustments and evaluation to align the model's outputs with ethical standards and societal norms. The future of LLMs. The future of LLMs is incredibly promising as they continue to evolve and expand their capabilities. We are moving forwards AI systems that can interact with us in more human like ways. As LLMs grow, the focus remains on responsible development. Ensure they serve the greater good. The journey of LLMs is a path towards more intelligent, empathetic, and efficient AI interactions. Okay, let's talk about tokenizations in LLMs. Tokenization is a fundamental process in LLMs where text is broken down into smaller units called tokens. These tokens can be words, subwords, or even characters, depending on the model's design. Tokenization is the first step in enabling LLMs to process language, transforming raw text into a format that the model can understand. It is a crucial part of the model's ability to interpret and generate language. Let's talk about attention mechanism. So, attention mechanism are at the heart of LLMs, enabling them to focus on relevant parts of the input data. These mechanisms help the model determine which parts of the text are most important for a given task. Attention allows LLMs to process language inputs more efficiently and accurately, leading to better performance in tasks like translation and summarization. It's a key factor in the model's ability to mimic human like language understanding. Mm, Next, let's talk about positional encoding. So positional encoding adds a layer of depth to LLMs, informing the model about the order of word in a sentence. This understanding is crucial for grasping the context and meaning behind language sequences. Positional encoding ensures that the model doesn't just see words as a bag of tokens, but understands their sequences and relationship. It's a crucial component for maintaining the flow and structure in language processing. Pre-training objectives. In the pre-training stage, LLMs are taught to understand and generate language based on large data sets. This stage involves objectives like masked language modeling, where the model learns to predict hidden words within a text. Pre-training sets a strong foundation for the model, equipping it to equipping it with a broad understanding of language patterns and structures. It's a crucial phase in developing a model's general language capabilities. Masked language modeling. Masked language modeling is a popular pre-training objective where certain words in a text are hidden and the model is tasked with predicting them. It's called the masked language modeling. This objective helps the model learn context and improve its predictive capabilities. It's a technique that trains the model to understand language in a comprehensive manner, enhancing its ability to generate coherent and contextually relevant text. Next, let's talk about instruction fine tuning. Instruction fine-tuning is an advanced stage in LLM training process. Here the model is trained with additional prompts or instructions, enhancing its capability, its adaptability and control. This method enables fine-grained control over the model's outputs, making it more responsive to user queries. Instruction fine-tuning is crucial for improving zero-shot generalization and performance on specific tasks. Parameter efficient tuning. Parameter efficient tuning is a fine-tuning approach that updates only a subset of the model's parameters. This technique is resource efficient, allowing for rapid adaptation of LLMs to new tasks without extensive retraining. Methods like prompt tuning and adapter tuning fall under this category. They represent a shift towards making LLMs more adaptable and accessible for various applications. Distributed training techniques. Distributed training techniques are essential for efficiently training large scale LLMs. Techniques like data parallelism, tensor parallelism, and pipeline parallelism distribute the training load across multiple processes or machines. These, these strategies enable the training of complex models by managing computational resources effectively. They are key to handling the increasing data and model sizes in LLM development. Alignment tuning. Alignment tuning is a critical phase in LLM development, focusing on aligning the model's output with human values and preferences. It involves training models to generate text that is helpful, honest, and harmless. This process often uses human feedback to continuously refine the model, ensuring its outputs are ethically aligned and socially responsible. It's a crucial step in responsible AI development. Alignment unit. Next comes LLMs and AI. So LLMs represent a significant advancement in the field of AI. So wrapping it up, offering more human-like interaction capabilities. They are reshaping how we interact with machines, making communication more natural and intuitive. The development of LLM is an ongoing journey, pushing the frontiers of AI to new heights. As we advance, the focus is on leveraging these powerful tools for the benefit of society. Thank you for listening to the presentation. Bye.